Welcome. We're going to go ahead and attack our last discussion of this week by doing more of the same, more induction. And again, I'm going to have some general problems, and then I'm going to do some individual problems. So I'm going to do a couple examples, and then I'm going to make some assignments for each of you. So the general problem, the first general problem is this one. Now, for this one, excuse me, couldn't hit pause fast enough. All right, so for this one, we are going to simply leverage the fact that r minus 1, oh, that's a typo. This should be the summate r plus 1. This should be a plus. Okay, so we're going to add up all these terms. So this thing over here, if I really wanted to, I can change the left-hand side of this equation just to make it easier. This is giving me the summation from k equals 0 to n of r to the k. Because really adding up all those terms, again, is summation. Now I'm doing that because, again, the ability to move between the two different notations is highly valuable in understanding what they are and just kind of interpreting and understanding this thing. So in this theorem, I'm going to go ahead and do this for you. So our base case is going to be the situation where n equals 0 because, as it says here, n is bigger than or equal to 0. So in that case, we have the summation from k equals 0 to 0 of r to the 0, which is r to the 0, which is just 1. Of course, that is assuming that r is not equal to 0, but we'll go ahead and stick with that. So the other side is that r to the 0 plus 1 minus 1 over r minus 1, which is just really r minus 1 over r minus 1, which again is 1. So these things are equal. We're good. So our induction hypothesis is that for n equals k, the summation, wait, I can't use k because I've already got it elsewhere. See, this is the thing. You got to double check, and my instinct was to use the k, and then I remembered I'd already used it. So n equals j, the sum from k equals 0 r to the k is equal to r to the j plus 1 or minus 1 over r minus 1. Now, there is a way to prove this one directly, really multiplying both sides by r minus 1. You're going to essentially get a telescoping series over on the left-hand side. And we could do that, and that would be a beautiful, easy situation to deal with. But we don't need to really deal with that. Anyway, so in this situation, so instead, our induction step is we're going to consider n equals j plus 1. Well, in that situation, now I have the summation from k equals 0 to j plus 1 r to the k, which is obviously equal to r to the j plus 1 plus a summation of k equals 0 to the j r to the k. But this, by our induction hypothesis, is r to the j plus 1 plus r to the j plus 1 minus 1 over r minus 1. Again, hopefully your work's a little more organized, you got more space. And this thing I can write as r j plus 1 times r minus 1 over r minus 1 plus r to the j plus 1 minus 1 over r minus 1, which in the end is just going to be r to the j plus 2 minus r to the j plus 1 plus r to the j plus 1 minus 1, all that over r minus 1. As you obviously can see, the middle part's going to cancel out. So we get our desired answer, which is r to the j plus 2 minus 1 over r minus 1. And we're done. So by the property of induction, mathematical induction, we've shown that this is true by using the previous step. So this is the really beautiful scenario here, is that we actually can work our way through this. All right. So let's just consider for a second. Sorry, I lost my controller. The next problem. So our next problem is this summation of terms. You're going to have to figure out, I would recommend this in terms of adding up all of the left-hand side and then moving on to the other two. And so what I'm going to do is I'm going to assign this one, and this one is going to be assigned to Alejandro. So Alejandro, you need to work on this one and show that this is equal to this when n is greater than or equal to 3. And you can test it out. You can work on different things. Your base case will work out in this one. And go ahead and just kind of show that it's true. And by the way, if you're going to do this, realize where does it start at? I would actually do a summation that doesn't start at 0, but starts instead at 3. And then it'll be much easier to deal with. All right, so you can kind of get the idea. This is pretty straightforward. So Alejandro, you have the first one. Our second one, the summation, this one is for Jackson. So Jackson is going to do this one, which you're showing that this summation on the left-hand side is equal to just this right here. This is, again, a well-known identity inside of calculus, but you're going to prove why that identity is actually true, again, using induction, rather than calculus uses some other things where we talk about limits and some sums and some other concepts like that. You can use telescoping series and such to make this actually go away. So we can kind of leverage different aspects. The third one, this is going to be Cameron. And again, Cameron, you're going to have to come up with what is the formula for this one. I would recommend what's the formula of this side, and then compare that to this over here. So it takes a little bit of creativity. You're going to actually have to create your own summation and figure out what is the formula that I want to use, where is it starting, and where is it going to. Next problem is actually this one. And again, I'm going to give this to Alejandro. So Alejandro is going to get this problem. And you're showing a divisibility problem now. So how can I show that 3 to the 3n minus 1 is divisible by 8? So this is the divisibility problems, but this is going to be a little bit more different than some of the past ones that you've probably taken on. Just think about what happens when I increase n by 1. The second one will be Jackson, who will go ahead and just attack this problem, which is similar to the one that Cameron's doing for the first one, but now we're adding factorials into it. So make sure that you consider, how do I deal with an inequality? So I'm trying to show that n plus 1 factorial is bigger than 2n, as long as n is bigger or equal to 2. And that's kind of a critical concept here, because your base case is 2, so it's 2 to the second, which is 4, and 3 factorial, which is 3 times 6. So you're going to have these things growing. You have to try to, again, this is an induction proof. There's other ways to prove this and so forth. Last but not least is Cameron, you're going to have this one, which is another divisibility one, but this is a difference divisibility one. So you need to figure out how to show that this whole thing right here is divisible by 4. And that's going to be an interesting trick. By looking at the base case, you may want to have to look at a couple things and then see, what do I see is going on between the first few cases and so forth, but you can do this. All right, that's your assignment. I want you all to work your way through these problems, but then to respond to other people's attempts on the different problems to kind of help all of us move forward by attacking a different variety of problems. So I'm kind of changing it up a little here. Some of you then want to give you a problem, your assignment for the homework, it's going to pull from these different subsets of problems, allowing you to kind of attack some different things. All right, good luck, and let me know what questions you have.